Welcome back, physics fans. Here we go with question 30, then 33 from the acceleration worksheets, the WaxOn, WaxOff worksheets. First of all, I'm going to do 30. And 30, the only difference in this question is it uses the word displacement. In 30, it asks for the displacement. So let's just go ahead and do that just so we understand what's going on. A drone is flying east at 9 meters per second, so we have one piece of information there, and accelerates west. And it's for 7 seconds. So those are our three pieces of data here. So we'll have initial speed is 9 meters per second east, and the acceleration is 4 meters per second squared west, and the time is 7 seconds. Now, you have to choose one of these to be positive, one of these to be negative. I'm going to make this positive and this negative. It doesn't matter which one. And then the distance is what we're trying to find out, or the displacement. Displacement is equal to VIT plus 1/2 AT squared. So D is equal to -9, 7 plus 1/2 +4 and T 7 squared. So this is -63, and this is 2 times 49, which is 98. Okay, and this becomes 35, and it's positive. So the answer for this is not this, but is the displacement is positive, meaning west. So 35 meters west. And that's how to do it for displacement. Okay, let's just move this down. Let's try to understand what's going on here. It is starting at a particular location, and it's headed east at 9 meters per second. But it ends up going west 35 meters. So this is the velocities up here. This is our distances. So it ends up going 35 meters west. So initially it has to do something like this, and it's going to move like this. It's going to stop. It's going to stop there, and then it's going to head on back and come down there. And the displacement, the formula that we get, is accurate. It measures the distance from here to there. And it's the displacement because we get the direction as well. But it starts here, and how much time does it take to stop? Okay, if it's starting at 9 meters per second and it's changing by 4, it starts off at 9 meters per second, negative, and then we add 4 to it. So after 1 second, it'll be going -5 meters per second. And then after another second, it'll be going 1 meter per second. And then maybe another quarter second, because it's changing by 4. All we need to do is here. So this will be like 1 second, 2 seconds, about 2.25 seconds till it stops. So it'll take 2.25 seconds to get here. And then it's going to fly all the way back. Okay? So we have to understand what happened. And our formula accurately gives us the displacement. That's what this formula does. It gives us the displacement from here to there. I want that to sink in. But now I'm asking, what is the distance? What is the distance? The distance is a different question because I want to include this blue part as well as this dusty rose part, because the distance is that plus 35. Okay, so really all I need to do is find out how big the dusty rose part is, or the blue part, multiply it by 2, and then add 35. Or I can do it this way. I find out how big the blue part is, and then I calculate how big this long part is. Because what happens if I didn't know it was 35? In fact, you don't get 35 from the question. You have to calculate 35 beforehand. So if I said, here's question number 33, do it. You didn't have the 35. Let's show you how to do it. Wow. Undo that. Draw. Let's put it down here. Okay, so we understand now that it starts here, it goes to a stop, and then it goes all the way back this way. So these are distances. So we have to consider both of them. We have to do them separately, because if we try to do it combined with a displacement formula, we're going to subtract here, and we don't want to subtract. So we do the first part and then the second. The first part has an initial speed of negative 9 meters per second and an acceleration of 4 meters per second squared. And here is the light bulb moment. The final velocity is 0, because at this point it stops to turn around and go back. So I want to know that distance, and I want to know that time. So the distance I get from VF squared is equal to VI squared plus 2AD. 0 is equal to negative 9 squared plus 2 times 4 times D. This is going to be 0 equals 81 plus 8D. So D is going to equal negative, because 81 goes over there and becomes negative, and it'll be 10.125 meters. Is that okay? Thumbs up? Got it? And then the time, do it without the distance. So we'll use VF equals VI plus AT. VF is 0 is equal to VI, which is negative 9 plus 4T. And as we got before when I was talking about it, the 9 goes over there, becomes positive, then divided by 4. T is going to equal 9 over 4, which is 2.25 seconds. Okay? And the negative just means it went this way, because the negative is east. Okay? And then the last part of the flight, it goes for 7 seconds. So the time of the second part is 7 minus 2.25. So this is going to be equal to 4.75 seconds. The initial speed is going to be 0, right from here, going that way. The initial speed is 0, and the acceleration is 4. So these are our 3 pieces of data, and we want to find out the distance. So the distance is equal to VIT plus 1/2 AT squared. So 0 times t, so that just disappears, plus 1/2 of 4 times 4.75 squared. So d is equal to 2 times 4.75 squared. And Mr. Calculator comes on up, and we'll go 4.75 squared times 2. This equals 45.125 meters. Okay. Now, if it's distance, we add this and then add that. So we, even though they're negatives, we just keep on adding them together. So the distance traveled is equal to 10.125 plus 45.125. So that's going to equal 55.25 meters. Okay, and let's just check displacement. Let's just check displacement. Displacement, if we go this way and then this way, they have to subtract. They have to subtract. So displacement is negative 10.125 plus 45.125. And that equals 35 meters to the west. That's so cool. We've solved 33 and 30 just by looking at it this way. Okay, so the trick to doing a distance one is you have to look at it till it stops. You have to look at it till it stops, because once it turns around, the distance is increasing, but the displacement's going back, going down. So that's the key point. You have to go to where it stops. So both of these calculations, VF was 0, and over here, VI was 0. Okay, thank you, physics fans. Hope you enjoyed that. Smash the like button, subscribe.